Thank you everyone for coming to our presentation. My name is Nidhi. My two teammates are Aparna and Nithika, and we are going to be presenting on our startup idea, Copple A.I. And here is a picture of all of us. We are all in the engineering management department. So a quick agenda. First, we'll go through an introduction, give you some quick information about our product and mission statement, an idea of the market and the competitors that are in the market. We'll talk about AI, the technology that we're going to use, and then we will finish it off with some time for questions if anyone has any. So the problem statement, just to give you some background information, construction is one of the oldest industries in the world. People have been building structures for hundreds of years, and despite that, it has been found to be one of the least digitized industries, according to McKinsey Global Institute. Part of the process in construction relies quite heavily on technology, and that's like architects using computer-aided design software, but other parts of the process are almost entirely manual. And given that productivity and efficiency in the construction industry is so important, it can mean millions of dollars, it can mean weeks worth of increased work. We believe that the adoption of AI technology in the construction industry can have drastic improvements on productivity, cost savings, and a reduction in risk. And so our mission statement is, with Copple A.I, we aim to create a new paradigm for construction that empowers the current workforce to be dramatically more productive and free from the repetitive, physically tasking, and dangerous tasks. We believe in the power of technology to transform the way we build. It is our mission to improve the quality and affordability of the places that we live, work, sleep, and play, while simultaneously improving the working conditions of the people who build these spaces. And you will see on the side here, we've made two logos. The name Copple A.I is supposed to represent the cobbling together of materials, but also the use of artificial intelligence. Our website is going to be coppleup.ai. And as you can see from the logos, there's a picture of a building to tie it back to construction, and also that 3D imaging that it shows will in part demonstrate how our product is going to work. And so what are we going to do? What is Copple A.I? What are we going to produce? And we're going to be a software company that targets, it's a holistic solution, and it targets two markets. So the first is the architecture industry. We are going to build AI, we're going to use AI to build accurate 3D models for small scale versions of diagrams with great precision. We are helping architects also test different types of materials to determine strength and flexibility and offer up recommendations. And so we, in the construction industry, we're also going to use deep learning algorithms to process, evaluate, and inspect large amounts of data that is captured on a construction site. And so the next part of this, we're going to talk a little bit about the market itself before we go into our specific offerings. And so the construction industry is a very large market. It is a $10 trillion industry. In our target market specifically, there are 700,000 construction companies, 21,000 architecture companies. This means that the potential for our total addressable market is actually very large. And it's shown in the number of competing products that are already available in the market. And so here is just some of the current existing solutions that are out there. If you are an architect, you would typically use one of these CAD softwares. There's AutoCAD, SketchUp, for example. And then in construction operations, which is a less penetrated market, there are some startups that are using AI technology, for example, Quant and Insight. And we will talk in a little bit more detail about these different competitors. And so just a quick overview is that technology has been used in the construction industry for decades to make jobs more efficient and safer. And A program like AutoCAD, for example, is used by architects to make 2D drafts of drawings, and then they can also use it to convert those 2D drafts into 3D models. The monthly cost of a software like AutoCAD is around $200 a month, and it has become an industry standard. It helps architects drastically improve their efficiency, but it doesn't use any artificial intelligence. And so it's still a pretty manual process. Now, AI in the architect sphere has become increasingly popular. It's a $10 billion industry, AI specifically, and SolidWorks is a recently launched company that uses AI to guide architects on the production of their designs. And so they will actually allow users to express a few parameters and then provide recommendations on the designs that will come out of those parameters. They also actually use default designs from previous designs to help give you values for shapes, thereby reducing some of that repetitiveness that comes from these tasks. Now, how our solution differentiates is that while we're targeting the architecture industry, we're also targeting construction operations. And construction managers currently use AI to schedule tasks, to prevent delays, to help mitigate conflicts. And this is actually an especially important industry to be in, just because with large-scale multi-year products, it's very hard for one person to oversee all of the different constraints and tasks that are associated with it. There are changes in designs, blueprints, permit delays, and so using pattern recognition, deep learning, we can actually help drastically improve on that process. And so some of the current players in this market is Quant, for example. They increase productivity by using sensors and AI-powered predictive analytics. And then Insight uses computer vision technology and deep learning to turn heavy machinery into smart robots. And so where do we stand? We know a little bit about the products that we're, or the markets that we're trying to target, but how are we going to do this? And we're hoping to offer a low price, high quality solution. And so the aim is actually to be priced 15% less than market rate for each product offering. And this is because while we offer to cover a broad range of services, we will not initially have the same specialization and depth that a lot of the competitors that I just mentioned have, just because it takes a long time to build and we are just starting off. And so to start, at least, we are hoping to take a more blanket approach on our software and then build specialization with time. And so this model we think will work for us because while we're leaving money on the table with each individual product, because we are offering solutions that go from inception to completion, we hope that the aggregation of the different solutions that we're offering in our software will actually help us win in the long run. And so the convenience of having one program throughout the entire process is going to serve as a unique selling point, we think. And so for the business plan canvas, just a little bit more information on our key partners, which is our target audience, the construction industry and architecture industry. Financial planners will also play a key role in this decision-making process, and then marketers, just because of the learning curve that's needed to teach people about AI and predictive analytics and deep learning. And so the key activities that we're hoping to perform are to create our software, create our technology. It also involves local management of the market, just because construction operations are a very local type of business. And so to be very involved in these local markets will help us sell our product. And then advertisement, again, another method of managing our inbound revenue. The key resources is partnerships with local companies, technology, and human resources that we're hoping to build. Our value proposition is for the construction industry, we are mitigating risk, we are a cheaper option, we're increasing efficiency. And then for architecture, we are offering a better product just because we're going to be building our own software, which we'll talk a little bit about later. And then we're also producing faster results. And then with customer relationships, it involves customer service and training. And our channel of sales is direct sales and search engine optimization, which is very common for SaaS companies. And our customer segments, which I spoke about previously, are construction and architecture. And then the cost structures that we will be incurring, which Aparna is going to talk a little bit about later, is the technology cost, the human resources cost, and the marketing costs. And our revenue streams, we believe to start off with, are going to be the sale of our actual technology, and then also an annual SaaS revenue, just because of the nature of our product offering. And then an analysis of the SWOT analysis of the market. So we believe our strengths are innovative technology. It's all going to be built in-house. It's going to be new. Improved efficiencies. We're hoping to solve some of the issues that the current market players have, and also cover both the construction and architecture side of the market so that it integrates together, and then less room for error just because of that integration. Our weaknesses are, this is an untested solution. We're new on the market. It is expensive to develop. It is software, but someone's going to have to build all of it. And then there's a learning curve. This is not technology that people are previously familiar with, and so they will need to become accustomed to it in some form to become an expert. The opportunities, the large TAM that I mentioned previously, the potential for high cost savings. And so this is both with the use of technology if you're not using any, but also if you're already using technology, aggregating products can actually help save money. And then first mover's advantage. So because we are making this unique product, there is no one else that is doing that same thing in the market. The threats that we see in the industry are low tech alternatives. And so both with construction and architecture, you can use no tech at all. And if you're small enough, it can be a potential solution for you that will work. There are also technology-enabled competitors, which we spoke about very briefly previously, some of the competitors that are in the market. And then the legal and regulatory barriers that come with working in construction and these high risk, high capital industries. And so next I am going to talk, I'm going to pass it on to Aparna to talk a little bit more about the market.
Thanks, Nidhi. As Nidhi was telling about the SWOT analysis, I'm going to talk about Pestel. Both are tools used in the management technique. So the Pestel analysis is an objective to find out how the external and the internal factors affect the industry. So to talk about political, I can say that there is a rising demand for AI in the construction industry, and that is an opportunity for us. But there is a threat which is like varying complex regulations and the legislation in each country. And the economic factors, we have a stable economy in the country, and also that is considered as an opportunity. As far as threat is concerned, all the consumers may not purchase it instantly because we are a startup company, so we need to have a good marketing strategy for the construction company to accept us. And the social factors, it is like the acceptance of AI-powered construction and the awareness of this technology. The technological factor will be, as this is a new software, we will be requiring social media to do our marketing strategy, and also it is lower cost to upgrade the technology. The environmental factor, it depends upon the surrounding environment. Maybe now due to COVID, not everyone is able to go directly to the workplace, but with our solution, you can do it if you have an internet and the software available. And the legal factors is internal laws within the company as well as the external laws. We need to look into it. Nidhi, can you go to the next slide? So Nidhi has explained about the business plan. I'll talk about the business strategy we are going to use. We are going to do marketing as well as the customer service, since it's a service provider company, we need to provide service even after the software is being delivered in case of any technical glitch with the software. Regarding marketing, I'll talk in the coming slides. So why we chose AI is because of the following reasons. The main thing is optimize schedules, which is AI can produce millions of alternatives to do the project delivery and planning, and also it will identify the unsafe behavior. Since the construction industry, there are many accidents happening, we can use image recognition systems and access the video data to identify whether it is safe or unsafe for the people working over there. And analyze pattern, we use the IoT sensors to understand the pattern and prioritize, and we can prevent the unplanned downtime. The risk forecasting, this is the good feature of this, because if we can forecast the risk, maybe we can mitigate it or we can give prioritize to the risk. The compare design plan, we can compare the final output with the initial design with the image recognition software. And the improve building information modeling. This is the important architecture term which is used in the current construction process. I will talk about it in the next slide. The cobot assistance is it will work alongside with the humans to help up with the construction, and it will reduce cost. The image recognition and analysis, AI is used to categorize and tag photography identification and analyzing the safety hazards. Next slide, please. So this is a business model with AI. So we have the architectures and planners. They will develop the new software, the generative design. They'll reduce the effort in planning, and they are threatened by other players. The construction companies, they can track lifetime in real time, and also we can use autonomous machinery, which will reduce the time for search of tools and materials, and it will improve safety. The facility managers, they can control the building using the technology, and they can improve their decision making. The building materials or material distributors or merchants, we can find the optimal points in time to procure the work done. So also we can optimize the inventory management. And the final is building material manufacturers. So we can improve the quality and reduce complaints, and the optimized formulation and production, and it reduces the downtime. So this is the business information modeling is actually vital in the modern construction. It actually enables developers to create a centralized digital database. So you can, it is not only helpful in planning, but it is throughout the life cycle from inception to the demolition. So the risk management, as AI has the risk forecasting methodology, we use the algorithms to analyze the risk so that we can keep the construction site accident-free. And AI-powered technologies like drone and image recognition can be used to prevent any accidents. And these techniques will help the contractors to identify the hazardous areas and devise mechanisms to improve the safety for the workers. Next slide, please. The key roles, I'm the project manager of this project. Nidhi is the process owner, and we have the business analyst as the leading manager. For hiring, we are looking for full stack developer, data engineer, and HR for our company, since ours is a startup company. The market strategy we are using is since it's a service provider company, we give subscription based on monthly or yearly, whichever the company is together. We basically show the visual of how our software works, so that it will gain more more companies joining our software team. The target customer, Nidhi has already explained in the business plan. We are looking out for the construction company for using our software to do their business needs. So the market and competitive challenge, as we are a startup, we will be a new entrant, will be a threat to the already existing other companies. And we are not a substitute to anyone. We are a new startup which we have created to do the modeling. And advertising, we use to social media as an advertising platform to advertise our product. And since we are using robots, we will not be able to adapt to a real-time variability because without our software works with the existing data. Next slide, please. For the project timeline, we have used Gantt chart. This is actually a visual view of tasks scheduled over time. So the planning and analysis phase we completed in May, where we came up with a rough idea of what to do with the project, and we did a market research of how to start up and what will be the prices and all. And the design and development we completed in June month, and the testing has been completed in July, and now we are ready with our software to be shown. We have a demo of our software. Next slide, please. So how our software can help? It actually lowers the operating cost, and performance is great compared to other software. And also, even if it is a repeatable task, our efficiency has been improved, and it's custom developed. It's based upon each construction company, because we are going to use their cameras to use our software to monitor. So we are not going to provide cameras in our project. We are just providing the software, and automated and improved logistics and management, so that we can look into the hazardous site conditions and the lack of transparency and corruption, and we also meet our sustainability goals. Next slide. So this is the generative design I was talking earlier. So here the goals and constraints are given as input, and the software will explore all possible permutations of a solution, and it will quickly generate the design alternatives. So it is being tested and learned from each iteration what works, what doesn't work. Next slide, please. I'll give it to Nitika Agarwal for the technical side.
Hi everyone. So far we have covered the market and the business strategy, but the technical part is basically divided in few sections. So the usual task of generating a 3D model for any building, it consists of you go from blueprint to a CAD model, and then from a CAD model to a 3D reconstruction, and then to a 3D model. What we are offering is you go from a blueprint, which is in 2D, and we'll give you a 3D model along with building information management data. So with the process which takes place where we are talking about the blueprint to the 3D model is the generative design and the topology optimization. And the generative design that we are talking about is the AI-based generative design. So in a usual generative design, what happens is that you have somebody who is generating those possible permutations, and as you can guess, there are so many constraints that you can provide, and a human being or a software which is not exactly specifically built for those can give you all the possible permutations. But when with our design, you can actually get all the possible permutations that you can get given all the specific requirements. Nidhi, next slide, please. So this is basically that the pipeline that I was talking about. You go from floor plan to the layout to the building model, and then you go to the spatial hierarchy that you will use for building information management software. Next slide, please. So the AI-based generative design, we actually have a demo for that. So these are the 3 steps that we are talking about. So the first step is it's a footprint. So you basically go to a city website and they have all the GSI data there. It doesn't even cost any money. You can get a plot size, and you just give that plot size to our software, and it will give you the best possible layout that you can fit in that plot size. And after that, it will give you given where you want the door and the windows, it will give you how you can divide up that space for your specific requirements. And the third option is, which is not exactly ready, it's still conceptual. You can lay out the furniture if you want to be. Excuse me. So, sorry, you have to go back. As you can see, basically our software, it generates colored pixels. So it's not basic. It's not. So if you have provided any input, which in terms of the color or anything, you will see it reflected in your final output. Next slide, please. So the step one that we saw, which was basically, which gives you the how should the plot look like, the layout should look like. We basically use this open source neural network called Pix to Pix, which is basically what it does is that you can give it an image, and based on that image, it will give you a render. And to employ this whole process, we have used Google Cloud Platform, their NVIDIA GPU optimization. This training, basically what it does is it takes all the layouts that's available on the city website, and then it learns how you can give you the perfect plot layout. Next slide. Next slide, please. So we have not taken the architect out of the whole thing. So what the architect needs to do is they can provide where they want the front door and where they want the windows. And based on that, it can generate all this different outputs for you. Next slide, please. This is an optional step. I haven't tested it that well, so it kind of works, but it's I'm not too sure about it. But what it's supposed to do is that it should give you how you can lay out your furniture, given this is the layout for you. Next slide, please. So this is basically the demo looks like. So there is basically, if you are an architect, you will give the plot size, and then you can define whatever the windows and all that stuff that where you want it. And in the future, we'll be adding a lot more constraints to it, that they can define what material they want and everything. Right now, everything is default to the most common one, but we'll get more options in the future. Next slide, please. The next part of the process is, so we got the layout for our building, and then we have to generate a 3D model. So for 3D model, what happens, at least right now, is that you have an architect which design that layout for you, and then you give it to an artist who would design a CAD model. But what we are offering is that you only give us that layout, and based on that layout, we'll give you a 3D reconstruction of that. And it's basically using two computer vision and deep learning techniques. One is the cost volume based multi-view stereo, and the other one is the directly regressing a truncated sine distance function. I know this sounds kind of weird. Let me explain what are they. Can you go to the next slide, please? So in a nutshell, the cost volume based multi-view stereo is that you have multiple cameras and you are looking at that one single image from multiple cameras, and based on that, you create this grid in 3D where you basically define the geometry of the structure. And when we are talking about the truncated sine distance function, so we have to store all that geometry that we computed in some form of function. So that's basically is the truncated sine distance function. And when we are talking about directly regressing it, so basically you have a ground truth and you generate this using our algorithm, how you can minimize the difference, the error rate between these two things is basically directly regressing is all about. If you are familiar with it, it's the least square function. Next slide, please. So this is what I said is in more detail. And so both of these things will give us the 3D model. And plus, when we add the geometry cycle consistency in this model, we will also get the spatial hierarchy that I showed before. Can you go to the next slide, please? So this is basically the demo of our algorithm that we provided the 2D layout, and given that 2D layout, we got this cool looking 3D reconstruction. Of course, it's not perfect. It's not as accurate as a CAD model will be as of now, but it's a step in the right direction, because a CAD model, it can cost, if you are hiring somebody to create you a CAD model, it can cost you a lot of money. With our software, it costs probably like 10 cents to build this. And the process, it takes less than 3 minutes to do all of that. And if you have a CAD model artist building all of that for you, it takes weeks, if not months. Can you go to the next slide, please? So just to reiterate all the data, 3D data that we have available. So we have a 3D model that we generated using that same algorithm. We can also output a voxel grid. A voxel grid is basically a graph in 3D, and you basically store 3D information in it. And using that, we also generated kind of like a spatial hierarchy of a graph, if you may. Next slide, please. So this is one of the core structure, the kind of like the meat of our product is the smart BIM. So one of the things that the current industry uses is, when they also use building information management, but it's not, if you want to use a building information from one building to another, even in the same construction company, it doesn't really work, because it's not updated. It's usually managed manually, and all it's very much reliant on specific software, which might not translate to one building to another if they are few years apart. So we are basically removing that manual process altogether and replacing it with the smart BIM. So what we are basically trying to do here is that we are trying to automate all the processes that somebody has, and that process involves, like you've already seen from the architecture point of view, but also when that's the stuff that you haven't even started construction yet. But now that you have started construction, it will help you automate all the processes that happens, and it will give you data to track that to track that everything is how it's supposed to be. We are also converting our 3D data into operational data, so that it can be used for 3D for the visualization, so that it's easier for people who are not into tech, or if you want to show it to your shareholders or whoever has a stake in that building, you can show them easily, and not basically they don't get irritated or annoyed by all the tech jargon. And we are also this smart BIM will also add as a link between the buildings that we are building currently, plus the smart buildings that everybody is talking about. You can't really have a smart building if you don't know how to manage the data. So we are providing a standardized method to actually streamline all that data and make meaningful sense out of it. So it will also help the construction companies to achieve their sustainability goals. And if they and we are also providing, I'll talk about it later, some of the deep learning algorithms that we have developed for cost optimization and risk management factors and all that. Can you go to the next slide, please? So so the first step in building the smart BIM is digital twin. So what a digital twin is, it's what it sounds like. You have a physical space, so you have a physical building, and you want to create a digital twin. So digital twin is different from what we were talking about in the 3D model. So digital twin is basically, it has a 3D information, but it also have all the other information in it. So it also should also have what kind of materials that you are using, what is what does the space look like in terms of what's the height, width, and all that, and what are the other regulations that they have to basically manage. It's also integrated with the schedule of the construction, the supplier information. So it has all these information attached to it along with the 3D information. And that 3D information is also translated into more operational data to separate what you want to preserve and what you want to use right now. So this is basically more information about digital twin. As you can basically see, the virtual model, it helps with operations, maintenance, construction, design, and planning. Our digital twin consists of combination of two kind of digital twins. So one is the structural model based and one is the machine learning model based. So what's the structural model based digital twin does is basically gives you all that information that you need about the geometry and the construction that's going on. And the machine learning models, it will give you all the information that you need about the operations that's been going on. So we have separated the two so that it's easier to separate the ownership of the data. So, and in those digital twins, each of them have 3 states, and those 3 states have another 3 states. So one state is the virtual twin, which is basically a virtual representation of all the physical assets. Second is the predictive twin, which is basically giving you whatever the behavior of the physical assets, how it should behave, and what would you need. And the twin projection is basically give you what are the operational processes. And even in those, you have a real-time model, and you have a dynamic model, and a steady-state model. Steady-state model is the model that you update once a week. Dynamic model is something that you update every 24 hours. And a real-time model is something that you've been monitoring all the time. And what information they give you, it varies. The real-time model will give you information about what if there are any accident or anybody got injured, or is there any delivery which is late that you need right now to complete specific tasks. So they are closely modeled with the construction timeline that we have. This is the levels of a digital twin that's supposed to how you can rate like which level that you are at. So most of the systems that exist in the market, they exist in the level 1 or level 2. Our system together as of now is at level 4, which basically we already have an UI which gives you all the metrics, and we already are using reinforcement learning to give you all the real-time updates. So the visualization of the data is, I don't know if you're familiar with Tableau or all these other tools that exist. What they do is they take your the 3D data that have been represented as an operational data, and if you give that data to those softwares, it can give you a nice visualization what it should look like. It's not a 3D model, it's just a visualization of the data, and it can help it can help as how you can monitor your progress in terms of how the buildings look like and how the other things look like without going into much more detail. So this is what we are offering in the visualization. So you provided the data, you can either get the full-fledged 3D visualization that we have provided, you can go into 2D, you can create charts and other things from it. So basically we're giving you all the options on that visualization.